Hey guys, welcome to eMaths. Let's do some maths for fun. Today, we will try a different approach to system of equations by using Gaussian Elimination. To solve system of equations, have you ever get frustrated by doing all hell long pure substitution? Or watch a 3 hours movie using elimination method? What if I tell you there is another method to solve those system of equations, which is the origin of those two methods? We will start with a demo. To solve this system of linear equations with 3 variables, first we write in augmented matrix form. As you can see, the numbers are just simply the coefficients from the equation. I will further explain about it later. Our goal is to make it into row echelon form like this, which means the system is now simplified into this. It's easier to solve now, isn't it? As we already got the 1 on upper left, just let it be there. To get the 2 zeros in first column, we first multiply the first row with -2 and add it to second row, because -2 times 1 is -2. -2 plus 2 is 0. Then multiply first row with -5, add it to third row, so we get that 0. Next, we want to get that red color 1 in the middle. Just simply divide the whole row by -9. Next, we want to get that second 0 in the third row. So, we multiply second row by 6 and add it to third row. 1 times 6 is 6. 6 plus -6 is 0. Lastly, we need a red color 1 at the bottom right. To do this, just multiply the whole row by 3/22, which is the reciprocal of 22/3. And we are done. Now convert this matrix back to equation form. Let it be equation 1, 2, and 3 respectively. As you can see, we already get the value of z. Now sub equation 3 into equation 2. Then solve for y. Finally, sub y and z into equation 1 and solve for x. This is the answer. X equals to 2, y equals to -1, and z equals to 1. Actually, there is another additional technique we call Gauss-Jordan elimination, which is used to further simplify the matrix into reduced row echelon form, which means we can read the solution directly from the column. But don't worry, I will talk about it in the next video. My question is, how do this Gaussian elimination work? To use this method, we need a basic understanding on matrix and row equivalent operations. For example, for this system of equations from earlier, can be simply written as a rectangular array of numbers like this, where the numbers in the first column represent the coefficient of first variable x. The numbers in second column represent the coefficient of second variable y. Third column for third variable z. And after separator is a constant, you should know that. Then the first row represents the first equation. Second row represents second equation. Third row represents third equation. This rectangular array is called an augmented matrix, which contains both coefficient and constants. Coefficient matrix, on the other hand, does not contain any constant. For all the augmented matrix, we can perform row equivalent operations, which include interchanging any two rows, must be the whole row, yeah? Multiply each number in the row by a same non-zero constant, or add a non-zero multiple of one row to another row. These are the operations we use to produce row echelon form, the one we saw just now. When we convert back into equation form, which is definitely much easier to solve, isn't it? That is the general idea of Gaussian elimination. Here are some of the tricks. If we want to make a real number a into 0, we can just minus a, which means add a negative version of it. If we want to make a into 1, we can just divide by a itself, which means multiply by its own reciprocal. Remember it, yeah? It will make our life so much easier later. Alright, are you ready? Start off. We will start with this example. First, we write the system in augmented matrix form. Bear in mind that our goal is to make it into row echelon form. And these are what we are allowed to do. As you can see, for this system, we can just interchange the first row with third row. Are we allowed to do that? Yes, first operation. Here we got that 1 in upper left corner. Next, we want to get those zeros in first column. We can use the tricks that I showed you earlier. To get that 0 in second row, we need a negative 2. Since we already got the 1 as first number in first row, we can just multiply first row by negative 2. And add it to the second row. Check if we are allowed to do that. Yes, third operation. Negative 2 plus 2 is 0. Write this into the matrix. And goodbye, my friend. We do the same thing to third row. Multiply first row by negative 4. Then add it to third row. We got another 0 that we need. Write this into the matrix. Next, we need a 1 in the middle. We divide the whole row by 5. Are we allowed to do that? Yes, because it means multiply the whole row by 1 over 5. Second operation. Do it at the side. Here we got the 1. Write this into the matrix. Next, the second 0 in third column. Like what we did previously, multiply second row by negative 5 and add it to third row. That's the 0 that we want. Last but not least, the 1 at right bottom. This one is very easy. Just divide the whole row by negative 12 and we got the 1. Goal achieved. Convert back to equation form. You can see we got z equals to negative 2. Let them be equation 1, 2, and 3 respectively. Sub equation 3 into equation 2. Solve for y equals to 4. Sub y and z into equation 1. Solve for z. And that's the answer. In short, our goal is always row echelon form. Focus on the 0 and 1. Do it column by column from up to down. To get 0, multiply previous row by negative of that number and add to original row. To get 1, divide the whole row by that number itself. And that's all for Gaussian elimination. Example 2. This time we will use back the standard elimination method, but we apply the concept of Gaussian elimination, which is we focus on the 0 and 1. Rearrange in such a way it's easiest for us to eliminate. Look at this, we already done with the first and second row. Let them be equation 1, 2, and 3. To get first 0 in third column, which means to get rid of that 3x in third equation, multiply equation 1 with negative 3 and add to equation 3. We let this be equation 4. To get the second 0, multiply the equation by positive 4 and add to the equation 4 from earlier. We got negative 12z equals to negative 540. Lastly, to get the 1 in third row, divide whole equation by negative 12. So, z equals to 45. Now sub z equals to 45 into equation 2. Solve for y equals to 120. Sub z equals to 45 and y equals to 120 into equation 1. Solve for x equals to 15. That's the answer. Look at what we did. We actually derived the elimination method from Gaussian elimination. An elimination method is what we commonly use, grad. However, what if the system has no solution or infinite solution? How do we know that? By using Gaussian elimination? Look at this example 3. Same thing, we arrange in such a way is easiest for us. Write in augmented matrix. Get the first 0 in third row. Write this into the matrix. Nice.
Hey, hey!
Are you sure about that? This row literally means 0x plus 0y plus 0z equals to negative 6. 0 equals to negative 6. Are you kidding me? This is what we call as inconsistent system of equation. In other words, there is no solution for this system of equation. Example 4. Infinite solution. First, we write in augmented matrix. We try multiply the second and third row by 3, so that each number in the first column is a multiple of the number above it. Next, we multiply first row by negative 2, add it to second row. We also multiply first row by negative 4, add it to third row. Row 2 and row 3 looks very similar, huh? Add them together and we can stop here, because this row means 0x plus 0y plus 0z equals to 0, which is true for all x, y, and z. Convert that to equation form. We only have 2 equations now. No matter what, our solution will contain at least one variable. Let's say we do it in terms of z. Let it be equation 1 and equation 2. Solve for y in terms of z. Y equals to negative z minus 3. Solve for x in terms of z. X equal to negative z minus 2. And this is the solution of this system, where z can be any real number. If we do it in terms of y, we will get this, where y can be any real number. In conclusion, if the system of linear equation has only one solution, the planes will only intercept at one unique point, and we can obtain a normal row echelon matrix. If the system has no solution, no common point, and we will get false equation in the last row of matrix. If the system has infinite solution, 3 planes will intercept along a line. We will get a whole row of zeros, and the solutions are in terms of one of the variable. Last thing for today, try to solve this system of equation with 4 variables using Gaussian elimination. I got this question from Kids to Kids tutorial. You guys can check his video on YouTube. It's very interesting. My solution will be in next video, together with Gauss-Jordan elimination. That's all for today. Thank you for watching. See you guys in the next video.